Service virtualization helps people in many different ways for many different scenarios. In this video, we'll take perhaps the most common one of them and use it to demonstrate step by step how virtual services work, how to create your first virtual service, and integrate it into your company's ecosystem. So take this health insurance app, for example, and imagine you're a part of a team responsible for its development and testing. The health insurance company you work for very much depends on this app, so you need to release new versions quite often. Your app is constantly under development and thus it's obviously not always stable. And unfortunately that holds true also for other company systems your application happens to depend on, like this one. So when it's up, your users, meaning mainly testers, devs or analysts, are okay, working as usual. Yet when it's down or doesn't work properly, which is quite often, they have to work on something else or simply wait. That will cost you a lot of money, well, unless you create a virtual service mimicking the original system to the extent your own healthcare app couldn't tell the difference. Reconfiguring your app to point to a virtual service is definitely worth the effort. In this way, you get help of a virtual man in the middle who can skillfully pretend to be the real system in case it's down, and when it's up, the virtual service can transparently forward the requests and responses to the real system, like if SV wasn't there at all. The topology I've just showed you is actually that of our familiar claim processing REST demo, which is available on any machine with SV Designer installed, even in the free community version, so you can try everything with us. In your Documents folder, find SV demo resources of the following demo. Then click this command file, and we have the demo up and running. This is our claim processing service, which is the healthcare app under test, the member account service, on which the healthcare app relies with data about patients and their insurance plans, and this is the refund form, a front-end GUI client used by hospital staff to file reimbursement claims for provided healthcare services. So let's try this out and file a new claim. Somebody has already pre-filled details for Mr. Hercule Poirot, requesting money back for some treatment at the dentist. So clicking Enter Claim will make the services produce an approval right away. Having a higher amount, an additional approval will be needed, like this. Now imagine what happens if the member account service is down or doesn't work properly. We'll have to replace it with a virtual service. So let's start the SV Designer and get the task done. What you can see now is the Designer Start page. There is a Welcome tab from which you are probably running this video. Also, there are certain shortcuts for tasks you do frequently, like for creating a virtual service via learning, which we'll be doing shortly, or for creating a virtual service from scratch, which will be covered in the simulation videos. Besides other things, you can also create virtual services based on traffic automatically discovered on your machine and other useful stuff. But for now, let's not take any shortcuts and go step by step. We'll demonstrate how we created this sample project from the SV samples. You can always open it from here should you want to have a look in the future. So let's create a project like this and call it Claim Processing REST Demo. Okay, now this is the SV Project Explorer. Currently our project is almost empty. Just notice we are running everything on the embedded server, which is a version of the SV server running inside SV Designer to help you design and debug virtual services. You could deploy the project to an SV standalone server like this. Here you would select a standalone server should you have one. Before we create a virtual service, let's run the demo again. It's all REST services, so you can decide whether to run it in XML or JSON format. For now, we'll pick JSON. And let me remind you, we'll be virtualizing the member account service, the purpose of which is to provide data about patients and insurance plans to our application under test. At this moment, we'll need the endpoint where the service listens, which is this one. Okay? Back to the SV Designer. This is how you create a virtual service. Here, if we had a Swagger file, like we have in the simulation videos, we could build the service from that. At this moment, we don't have any such thing, so we'll try to rely just on recorded traffic between our healthcare app and the member account service. In most scenarios, this is perfectly okay. So select this other option. Now click Next. Here, from the list of available protocols, we'll select REST. And on the next screen, we'll specify the service endpoint that we copied to clipboard a moment ago. These are some advanced settings you usually don't need to change, but let me at least comment on the agent field. For REST, and also for other HTTP-based protocols, you have several options here. Agent is one of the most important SV components. Agents are responsible for managing virtual endpoints for corresponding protocols. You can display a list of agents using this icon, or you can click here. There are many different protocols supported by SV, and there's usually a default agent defined for a protocol. You may need to create your own agent if you need some special setup for the hosted endpoints. For instance, say you have several SAP systems to integrate with, then you'll need to create an agent for each of them. Or you may have more MQ channels, or perhaps for HTTP, you may need to create a special agent with certain corporate proxy settings, as we'll show you later in this demo. I'm currently operating outside my corporate network, so I can perfectly do with one of these predefined agents. This time, I'll select the HTTP proxy. I'll explain how it works in a moment. Now press Next. Here on the summary screen, let's change the name of the virtual service to Member Accounts and press Virtualize. Okay, we've created a new virtual service. Here you can see the endpoint and also some other parameters. Also, there is a short summary of what else you need to change externally in order to make the virtual service work. So let's display it and let me explain how HTTP proxy agent works. So the main point here is you need to set up SV to be your machine's HTTP proxy like this. Okay, this will cause all of the machine's traffic to flow through SV. The SV server will transparently forward all the traffic back and forth, except for the endpoints specified here, for which the traffic can either be forwarded or simulated by SV. And you could have even more of these here. That's especially useful when virtualizing web pages that need many different endpoints for statistics, analytics, and other stuff. Another advantage of the proxy agent is you don't have to reconfigure your application under test to point to a virtual endpoint different from the real one. The tested app, in this case, doesn't need to know SV sits there as a man in the middle, replacing part of the traffic with a simulated stuff. So the HTTP proxy agent is very non-intrusive with respect to the application under test. On the other hand, having all traffic flow through SV may not necessarily be what you want or like for many obvious reasons. Never mind, there is an alternative to the HTTP proxy called the HTTP gateway agent, which we'll explain later. But now it's time to test our newly created virtual service. This symbol means we are in so-called standby mode, meaning all the traffic, including traffic going through this endpoint, gets forwarded to real systems. So let's try it out. At this moment, no messages have been intercepted. Okay, entering a claim for refund, you can see the messages are being intercepted by our virtual service and forwarded. So it's 8 messages, meaning 4 requests, 4 responses. And now another 8 messages for another entered claim. Okay, this means at this moment we've established connectivity, so we can learn the real service behavior from messages we're going to intercept and record, for which we'll need to switch to the learning mode like this. Okay, now let's call up the service again. Perfect. You can see we've recorded this amount of messages. We can now stop, and after a moment the recorded messages have been analyzed and you can see them here stored in Virtual Services data model. We'll explain the data model in detail in the simulation videos, which you are encouraged to watch. For now, suffice to say, in simulation SV tries to match the intercepted requests against one of these rows and provide a corresponding response. Well, it's actually much more powerful than that, so watch the simulation videos for more. Okay, now let's switch to the simulation mode to make the traffic through this address simulated by SV. Well, and before that, let's perhaps turn off the member account service. Okay, as you can see, it no longer works now. So, after switching to simulation like this, you can see the messages are being intercepted again, and the tested application works again, and nobody can tell the difference. And that's all thanks to the data we previously learned to the virtual service data model. So far, I've been operating outside my corporate network. So let's say I've just changed the networks and now I need to respect our company's proxy. That's actually a good opportunity to show you how to create a new agent. Opening the agent list, the place to set up a proxy for our HTTP proxy agent is here. But better to keep the default settings intact and create a new agent by duplicating this one. As all traffic is now flowing through SV, it's no wonder nothing gets displayed if you enter www.microfocus.com/sv in your browser. Yet if you provide the correct proxy here and start using the agent like this, it will begin to work as expected. To be honest, I personally don't use the HTTP proxy agent all that often. It's very non-intrusive, yet that comes with the price of having all the traffic flow through SV, which may be good for virtualizing web servers, but for virtualizing a tiny service, this approach may be way too heavy. I feel much more comfortable with exposing just a single virtual endpoint through SV and redirecting my tested application to that virtual endpoint. It requires some minor additional effort, but it's certainly worth it. And it's also my general experience with other protocols where we offer an intrusive and non-intrusive way of doing things. It's always a trade-off. So for exposing just one virtual endpoint, we need to use the HTTP gateway agent. We'll duplicate this one. This is the port where it will listen. It has been allocated automatically for us and can be changed if needed. Okay, now let's select this agent for our virtual service, and here you can see immediately how the virtual endpoint address looks like. We'll copy it now and reconfigure our demo to point to this new virtual endpoint address. To do that, I need to edit this command file, putting the new endpoint address there. Well, if these changes don't seem very straightforward, it's because configuring the tested app is always a bit project-specific. But you surely know the app you develop or test. So reconfiguring it to point to a different address shouldn't be all too complicated for you. Okay, when I restart the demo now and switch to simulation again, you can see everything works as previously. And this time, SV is exposing just this single endpoint. So, this was just the beginning. In the next 3 videos, we'll demonstrate how SV simulation works and how it can help you make your virtual service behave in a realistic manner with no coding, with minimal technical understanding of the underlying protocols, and all of that with just a couple of clicks.